Hi, everybody, and welcome to our third panel in the Future of Information Processing event series. My name is Christina Hattas, and I am part of the German Informatics Society, who is helping IFIP celebrate its 60th anniversary this year. And it's been 60 years since IFIP was founded following the first World Computer Congress, and we will be using this series to look what the future may hold. And with this, I would like to hand over to today's moderator, Moira de Roche. She is the chair of IP3 and also the director of the Institute of Information Technology Professionals of South Africa. So welcome everybody, and over to you, Moira.
Thank you, Christina. Right, so as you all know, this is the title of this session. We really want to look at how we can collaborate to get frameworks, etc., for the certification and education on data science. Now, come on, slide, go, go, go. Sorry, people, suddenly didn't want to move. Right, so just to give you a little bit of background about IP3, who I'm the chair of, and who's all about curricula and competencies and frameworks. IFIP has a strategic goal to advance professionalism in ICT, and you'll see how we plan to do it. And very strong amongst that is promoting common skills and competency frameworks. And that is really a very big part of what this talk will feed into, along with accreditation, ICT education, etc. And IP3 was set up to actually help IFIP achieve this goal. So IP3 are part of IFIP. If we look at an IT profession, or the IT profession of the past was really a very engineering related kind of business. But in the future, it's much more business focused with a base of both technical and business competencies. And we see that as we move into the fourth industrial revolution, the technical competencies are reducing with the bigger demand for specialist skills, such as data science, and non-technical skills, because in future we will have to have skills like empathy and creativity and so on. So IP3 is a global program promoting professionalism. We're led by IFIP, we're independent, non-for-profit, totally vendor neutral. We delivered through our member societies, that is the IFIP member societies, and we work at defining and developing global standards and international infrastructure. What we don't do is actually develop frameworks, etc. ourselves. Rather, we look at other frameworks and benchmark them against each other. And we did that for the general IT profession. We're currently working on a project looking at it for cybersecurity. And I'm hoping that an output of this session will be looking at something similar for data science. In other words, the specialism that hooks onto the core body of knowledge for professional. And we recognize the professional schemes at member societies, such as RT, ISPJ, and we promote trust in digital. For the panelists, in case you've forgotten, these are our speakers today: Tetsuro Kamashita from the IPSJ, Yuri Demchenko from the Edison Data Science Project, Boots Castle from ACM Data Science Task Force, Kewal Dariwal from the Institute of Certification of Computing Professionals, I apologize, Kewal, and myself. And how the session will run is there will be 5 minutes for each speaker to outline the activity. And then we will move into a discussion. When each of the speakers has finished, we'll move into discussion. The first topic of the discussion will be the current collaboration that those speakers have with other organizations related to education and certification. The second topic will be future plans for each organization. So the first topic we'll have about 3 minutes per speaker, the second topic about 2 minutes per speaker. We'll then have a little bit of further discussion amongst the speakers. And then finally, in the last 15 minutes, we will have Q&A with the audience. The best thing for you all to do, delegates, is to actually post your questions in the chat. In that way, you can post them as you think of them or as the speaker speaking. And then at the end, we'll pick them up and also make sure we ask, we aren't covering the same question. If we have a really interesting question and we have time, we might ask you to say it in live, but mostly we will just read out the questions. And then in the last 5 to 6 minutes, we'll have a wrap up with messages from the speakers and then concluding remarks from myself. Thank you very much. Let me just stop sharing. My goodness me. Can't believe that I'm having such a bad time with Zoom.
It's all right, Moira, we can see your slides.
You can. I don't want you to see my slides. I want to see you guys. I can't. Christina, if you're still there, are you able to stop my share?
We're not seeing your slides. We can't see them.
Okay. All right. Now I see you all and you can't see my slides. So all good. Thank you. Sorry about that. First on the menu today is Yuri. Over to you, Yuri. I've wasted enough time. Thank you.
Okay, so let me start sharing my presentation, and this is okay. So I'm happy to be first, but still it's a even big honor to do this first, because I know that many people refer to so-called Edison data science framework. So I try to explain background. The project was Edison project was funded by Commission in 2015-17 for 2 years, and task was to build data science profession or foundation for data science profession in Europe. Not even 2015, we were working with Commission to crystallize the offer, the requirement, the expected objectives for starting 2011. So it was for us quite a big work to win this call for proposals, and we actually did our job in such a way that we created a product that people using, referring, and I even not count how many users, references made for the Edison data science framework. And the most important, but okay, this also puts some responsibility for us and University of Amsterdam and few consortium members took responsibility to maintain Edison data science framework. And we did 2 editions after project finished, and currently working on the next edition, release 4. It will be my last slide. And currently we maintain everything on the new website, not that was original from the project, but also the GitHub repository. And you can actually look at the latest information. We are supported by few projects during the last years after the project Edison, and last year published book, the Data Science Framework View from the Edison project. And what actually Edison project delivered? First of all, it delivered so-called, Edison Data Science Framework containing few components. This will be next slide. We delivered competence definition and data scientist, data science definition. We delivered the professional profiles according to European classification. And also we made a quite big research with help of our students, PhD students, to develop a model how we can customize a curriculum based on required competences or profession that we derive from the professional profiles. And surely competences assessment and team building. And since the project ended and until now, at least 2 times a year, we do the market research to verify which new competences appear in the context of data science or new demanded profession like data stewardship. And we publish papers. Students are defending their project thesis and share the different conferences. And this slide shows the actually content of the Edison data science framework. Is a competence framework, body of knowledge, model curriculum, and professional profiles. And they are all together working if we need to find what is advisable in the curriculum for specific professional groups. And after that, surely this is a tool, it's advisory tool. We cannot dictate teachers or professors. And after that, based on this, professors decide what they can implement in their curriculum, which resources they have, and so on. And following this structure, we actually define the 5 competence groups, where is data analytics, data science engineering, data management is extremely important. At that time that we introduced this data management, nobody was not so keen, didn't recognize that data management become so big things now. And what we are introduced there, research methods, and this is what made the data scientist different from a data analyst or business intelligence specialist, because data scientist is using research methods. But interesting trick that until now, we don't have good courses on research methods for data scientists and for computer scientists. And we still are working to make this course around our network.
Thumbs up.
Stop? Yes, I can
Stop,
do.
Please. Okay, thank you. All right, next up is Boots. Boots, I will time you as well, and I'll play that silly song when 5 minutes are almost up.
All right, so I'm representing the data science activities at both ACM and ABET. And we're looking at curriculum recommendations at ACM and at accreditation criteria from ABET. So ACM has been in the business of doing curriculum guidance for programs in computing since 1968. ACM stands for the Association for Computing Machinery. It's obviously a lot broader than it used to be, but that was the original name. All the curriculum recommendations for all the programs, all the computing areas are available at this link, or just go to acm.org and click on the education link. We now have an ACM data science recommendation that's available at that link that's shown there. The task force was co-chaired by Andrea Daniluk and Paul Leidig. The work began with a proposal to the ACM Council. This actually started, Heikitopia and I organized a gathering of people interested, people representing organizations, representing various interests in data science and data analytics. That was actually in October of 2015. So we've been going at this for a while. It took 2 years to get the ACM Council to start formal work, but it has been very productive. So this is the body of knowledge for data science. The work is described in terms of knowledge, skills, and dispositions. And some of that reflects what we've just heard from the Edison project. We certainly did look at the work of the Edison project. In fact, we had a visit from the Edison project in our 2015 meeting. But these are the topic areas, the body of knowledge for data science. Analysis and presentation. Oh, I won't read them all, but you can see them. And I would like to point out in particular the emphasis on data privacy, security, integrity, and analysis for security. So the emphasis on data management in the terms of understanding the significance of the data and the responsibility of the data science community to protect that data, to make sure it is right, it's private, it's secure. There's also data acquisition management and governance, which has to do with getting the data and storing it and keeping it available. But this emphasis on security and privacy and the ethics of handling large data systems is a key component. Another key component involves programming and software development. We'll see that again. ABET, on the other hand, accredits college and university programs. They have component commissions in a number of areas. One is in applied natural science, one is in computing, one is in engineering, and one is in engineering and engineering technology. These are independent commissions within the ABET structure, and they carry out accreditation activities in those areas. As of this cycle, the 2021-2022 cycle, data science is now a recognized and available area to be accredited in both the computing and the applied and natural science areas. For computing, the criteria build on the existing criteria for all of computing programs and add a sixth requirement, a sixth required outcome, that the program graduates will have the ability to apply theory, techniques, and tools. Theory, techniques, and tools throughout the data science, the data analysis lifecycle, and employ the resulting knowledge to satisfy stakeholders' needs. These are the topic requirements, and I can't put up the ACM ones and these at the same time. These were two independent activities. There was some cross fertilization of the committees. I was on both. There is clear overlap, but they were arrived at independently. And again, the data privacy, governance, and stewardship is a key component. I want to point out that there is a single little line that says statistics and mathematics. A really significant component of both of these efforts is to recognize that data science is an inherently interdisciplinary activity. That it is not solely a computing activity. It is not solely a statistics activity. It is not solely anything. It does require the collaborative effort of a variety of disciplines. So that one little bullet that says statistics and mathematics represents, as a similar bullet in the ACM one does, that we have to have the input from the statistics and mathematics communities to elaborate on what those requirements are, what are the appropriate elements.
Boots, I'll have to stop you now. Thank you very much.
Fine. Okay.
Next up is Keval. Not sure if I'm pronouncing your name right, Keval, but please go.
Thank you. Yeah, it's Keval or Cool. So whoever wants to call it. No, it's Keval.
Well,
my mother calls me Keval, so this is always an interesting pronunciation.
That's how everybody should call you, how your mother says it. Keval, thank you.
Thank you. So I'm going to share my screen. So let's see if it goes. There we go. Share. So let's see. There we go. So the challenge is start from there. I will just carry on quickly to the challenges. So as we all know, data science is a subset of big data, databases, data warehousing, BI, and computer applications. We've got high quality, we have needs for high quality, accurate, and organized data, which can provide us some decision-making in context. However, the world is escalated with the data volume, and we face this acceleration in the manipulation of images, deepfake videos, private forums, anti-vaxxers, and so on, including the ransomware theft. And we face diverse ethical practices and data privacy challenges. And also we face an industry, I'm sorry to say, rife with delayed, over budget, failed computer applications and systems integration projects. So really data science and machine learning and artificial intelligence rely on accurate, unbiased data. The problem is we have bias existing around us everywhere. You know, who designs it? People that are working on applications, they're typically unknowingly biased. Who sets policy? Well, the dominant hegemony of the place and time really sets the policy on what is bias and what is not. And that's often not fair. So where does the bias exist? It exists everywhere. It's embedded in precedents and law. And who abuses it? Well, the technocrats today and the terrorists, okay? These are the multiple abusers. So ethics derives from the constructed reality and organization of society and the derivation of religions. We've got stories in religions that set our moral codes of conduct, rights, wrongs, principles, value systems, and legislated policies and procedures that allow us to live in peace with each other and not violate neighbors' rights. So in the technocratic monarchy, for the sake of convenience, we've given up our rights to complete privacy. And Facebook, Amazon, Apple, et cetera, have taken advantage of all that. These are the new technocratic monarchs. So our ACM Code of Ethics, which ICCP follows rigorously and makes sure our computer professionals sign up for it. So the challenges for us is how do we control our data? And the challenge is how do we move into making our profession much more professional? And I believe we need generally accepted data management principles and practices. And we need also generally accepted application development principles. And we've been working on this for many years, where we think you need trusted models of data security, core reusable data models, a global data ownership and transfer model, and rethink of the design of primary keys. I think primary keys have been horribly misused over the years, and we just haven't figured it out. We need a TCP/IP approach for this. And ultimately, we need an application framework and reusable interface designs so we can build robust systems on time and within budget. We need to get professional, folks. We require an engineering, production, and continuous quality improvement approach to move from craft development to volume production. So in summary, data science is only as good as and unbiased as high quality data, and we need to build our systems much better. We need to establish these generally accepted data management principles, application development principles, rapid application development frameworks, an ISO-style training and implementation registration system. And we need to rewrite our curriculum for the universities that focuses on these principles. And we need to make sure we start teaching integration from day one. So ICCP was formed in 1973 by Canadian Information Processing Society, ACM, the Institute of Electrical Engineers, and Data Processing Management Associations. So we're managed by the board of directors representing these organizations, and we offer universities and colleges a nationally normed learning outcomes assessment matched to the ACM outcomes, learning outcomes, and the ones that are at ABET. So our exams typically come out with a report for the colleges and universities to use for their ongoing accreditation and quality improvement. So we offer obviously a lot of certifications. We're one of the largest certification bodies in the world, and Certified Data Scientist is one of those. The requirements are that you do the Information Systems Core exam. So you have a computing background, you have a data science requirement, and a business intelligence and data analytics exam. And if you're passed at the 70% or higher, you're certified as a data scientist. If you do lower than that, you qualify as an associate. And we also have other entry-level certifications. And the reasons for seeking certification obviously are advancing in the profession and obviously more credibility, solve problems, greater self-esteem, and likely you'll get promoted and get an increase in salary. And employees become more productive, they're more respected by clients, and employees demonstrate that they fit with the job titles and job definitions at hiring and promotion. So we've tried to organize our exams by different sections of the segments of our industry, and we have certifications in each of those, and you can see some of the job titles. And obviously everybody from business to education to insurance to manufacturing take our exams. As mentioned, data has exploded, and the DEMA DMBOK, which is built a lot on the ICCP exams that we started back in 2003. And obviously business roles and IT roles have changed dramatically, and we have these new hybrid roles where data science fits in. So
I have to stop you there, please, Carol.
Thank you. Thank you.
Thank you. Right. Before I hand over to Tetsuro, One thing I should have said and said wrong in my introduction is please, if you have a question, post it in the Q&A and not in the chat. Contrary instruction to my first one. Thank you. Tetsuro, over to you.
Okay, thank you very much. Okay, so my name is Tetsuro Kakeshita, and today I'd like to talk about curriculum standard and certification on data science at the Information Processing Society of Japan as the chair of the related committees. We published a curriculum standard on data science this April. And also, oh, excuse me. Yes, we published a curriculum standard on data science this April. And we also accredited data science certification run by Hitachi recently. So at first, I would like to introduce data science curriculum. And these are the policies to develop our data science curriculum standard. In order to cover a wide area of data science, we referenced ACM data science curriculum and the Edison data science framework. We also designed the curriculum to collaborate with IPSJ data science certification. The data scientist skill checklist is referenced for this purpose. The curriculum size is approximately 675 class hours. This means that 50% of the required credits to graduate Japanese universities are assigned to our curriculum. And these three reference models that we use have different characteristics. ACM data science curriculum contains a detailed list of educational topics. It also contains priority of the topics T1, T2, and E. The Edison framework covers the widest areas compared with the remaining two models. The data scientist skill checklist mainly focused on detailed skills required for data scientists, which doesn't covered by the ACM curriculum. So we mapped these reference models each other to develop a curriculum having all of these advantages. This table summarizes the top-level categories and the assigned time of the IPSJ data science curriculum. Each topic is assigned a priority with a certain amount of education time. The time assignments are defined based on the Edison framework. On the other hand, each topic and its priorities are assigned mainly based on the ACM curriculum. However, these red topics, A and C and G3, are defined based on the data scientist skill checklist, since they are not covered by the ACM curriculum. And the second topic, IPSJ runs a certification program named Certified IT Professionals since 2013. This certification program has approximately 10,000 certification holders and is accredited by IP3 in 2018. The Japanese government defines 7 levels for IT professionals. Among them, the lower 3 levels are covered by the governmental examinations. However, working with experience and business achievement are also required for the higher levels. CITP covers these levels, which corresponds to Sphere level 5 and ECF level 3 and above. The IPSJ data science curriculum covers the contents for the data scientists of level 3. On the other hand, IPSJ accredits private data scientist certification of level 4 run by IT company. This policy enables delegation of the evaluation of the ability and business performance of the data scientists to each IT company while preserving quality assurance. From the viewpoint of each IT company, obtaining accreditation from IPSJ demonstrates the validity of their private certification. There are also other data science curriculum in Japan whose levels are lower than the IPSJ data science curriculum. IPSJ is currently building a data science framework by integrating the related activities. So this concludes a brief introduction of IPSJ activities. Thank you for the attention.
Thank you, Tetsuro. Very well done. You were pretty well spot on time. Okay, so now we're going to move on to a short addition from each speaker on current collaboration with other organizations around this field. So Tetsuro, if you can just stop sharing perhaps, or do you want it specifically up?
Oh, sorry.
No problem. So Yuri, if you can address for us in 2 to 3 minutes, current collaborations with other organizations around education.
I can do. Possibly I also, again,
go back to your slides.
Yes, I can do what is, somebody already sharing. So if you,
it's at the top. It's at the top of the screen.
Probably I. So,
okay, so now I can try to share. Okay, so I have one slide for this, is that we are actually cooperating this quite wide network of project communities, and this slide is just list 2 projects. First, that is focused on data stewardship professional competence development, and this will be also published. And the MATES project for digital skills for maritime industry, what interesting. And in both of projects, we use the EDSF, Edison Data Science Framework, as a basis to develop a specific profiles and framework. And big European project, EOSC, European Open Science Cloud, is also has a huge activity on skills. And also we cooperate with Research Data Alliance, but I'm impressed by formal approach by Boots and Tetsuro and Keval, how they approach to this development framework and certification. We are not doing this, but we are still developing and continuing development Edison Data Science Framework, and it's used by many as a reference, not direct as a standards, but as also as a example and reference to to derive their own framework. So this is my one slide. I think it's sufficient.
Thank you. So are you done?
Yeah.
Thank you so much. That was nice and short. Boots, if I can ask you to comment on your current collaborations with other organizations, please.
Yes, and I don't have a slide for that, but I referred to it somewhat in my previous slides. And I think the highlights perhaps are, if you look at the ACM criteria curriculum, you'll see that the work was informed by the work of other organizations, such as the Edison project, which is an incredibly comprehensive, really, really wonderful project that had a lot to offer. But it also, we incorporated the work of the national academies, also the Park City report, which is a data science curriculum recommendation developed with the American Statistical Association. They made a really significant effort to incorporate not just statistics, but other disciplines that are required. And they did a pretty good job of that. It definitely has a math and statistics slant, but that's a fine thing because we need that. So we bring that together. One of the things I want to mention is that both in the ACM work and the ABET work, there is an assumption that data science will be exercised in the context of some discipline, some application area. And that application area might be business. And so that tends to be called data analytics when they do it in business, but it's not necessarily business. It could just as well be in the sciences or the social sciences. It can be in the humanities. We have examples of people who are analyzing data that is text from historical records. There are application areas everywhere, and ongoing conversations need to be continued across every imaginable boundary, not just business, not just science, but every possible discipline has applications for managing large sets of data. And their needs have a lot in common. The computing parts of them have a lot in common, but they also have distinct needs. And so these collaborations. So ACM, I know, is working with the American Statistical Association. ABET, the kind of collaboration that's illustrated by the fact that both the Computing Commission and the Science Commission simultaneously introduced a data science criteria, and that they were what they call harmonized at ABET. They were made compatible, and they were introduced at the same time as compatible but different, reflecting the needs of these two different communities. So that's another illustration of a collaboration that I think is really an important example.
Thank you, Boots. Kiwal, if you would like to talk about your collaboration of ICSP with other organizations, please.
Thank you. Thanks. So let me share my screen again, and I'll talk about it from here. So we're really working with a lot of organizations like the Data Management Association with chapters, and we're working on and have built up the need for improving data literacy. And then we have an examination that covers, because a lot of the business people in the world don't want to do hard data related knowledge or testing. So we've been working with the Data Warehousing Institute, TDWI, what's now known as Transforming Data with Intelligence. And we've created this exam for those needs. Within the data industry, let's see if it'll jump there. We're working a lot with the vendors to try and figure out what they're doing. So trying to stay up to date with exactly what's happening in industry. And we are working with a lot of these vendors directly. We're trying to set up a big data lab for research and a play area within one of the colleges and universities that I'm working with here in Edmonton, Alberta. Also within the machine learning and AI industry, I'm on the board of the Alberta Machine Intelligence Management Advisory Board, and we have startup companies like Alta ML that are growing rapidly. And right under our noses are people like Richard Sutton on reinforcement learning and so on. And of course, University of Alberta, where our main machine learning and AI industry is right in within the computing science program. And of course, we've used subject matter experts to develop, so these are working practitioners to develop the framework for our exam in data science. And then we have a 12-week, 12-module online course that people can study on their own or have an instructor lead them through this. So this gives you some of the quick breakdown of the subject matter within that course. And at the end of it, we're working with people and companies to build a performance profile. So at the end of each exam, they get a detailed breakdown, and they, over 3 exams, they get a detailed breakdown and recommendations on what to study next. So we're also working with large organizations like Infosys from India, where we're looking at reskilling and retraining the unemployed workforce because we have a shortage of IT workers. And their model is to take people through an aptitude assessment, do some career counseling, get them through workshops, get them through training, and then take an examination at the end of it and then graduate. And we're also working on what are the core competencies for digital teams in the future, and try to make everything in terms of how do you handle customers, how do you handle their digital needs, and so forth. Other organizations like KIPS use our exams towards the ISP, which is, of course, a IP3 recognized credential. And then we work with other organizations to figure out what job types and what exams match with their needs. So that's it from me. And if you ever want to take an exam, you just come to the ICSP website. If you look at our website, you'll actually see all of the different exams and the content that's covered within each of those exams. We have business intelligence, data analytics. So some of these are summary and the exams are in much more detail. I think I'll leave it there. Thank you.
Thank you, Kiwel. Tetsura, over to you to tell us about IPSJ's current collaborations.
Okay.
Please.
Yes, let me share my screen. This is it. Yes. Okay. Data science is a quite hot topic. So there are many related activities done by other organizations other than IPSJ. So basically, IPSJ is willing to collaborate with these organizations. So this slide illustrates some of the activities related to data science, data science education and certifications. I have already explained the ACM curriculum, Edison framework, and the data scientist skill checklist. Other than these three, the consortium for mathematics and data science education, supported by the Japanese Ministry of Education, recently published 2 data science model curriculums at the literacy and the middle levels. Since data science education and data scientist certification are closely related, IPSJ has established a set of committees in charge of these issues. This is an entire picture of related activities and organizations from the viewpoint of IPSJ. I have already explained these 3 activities. The Institute of Professional Engineers Japan is an organization of professional engineers which is closely related to the CITP certification. The CITP certification is accredited by IP3. And the accreditation criteria of IP3 is defined based on ISO standard on certification for software engineers. And actually, there is an ISO working group developing this standard. So I would like to introduce this standard in the next slide. The name of the standard is ISO IEC 24773. This standard defines requirements to certification scheme for software engineering and systems engineering professionals. This standard has 4 parts. Among them, Part 1 and Part 3 are already published. Currently, ISO is working on and developing Part 2 and Part 4. Although this standard does not directly cover data science, it is the first ISO standard to define requirements for IT-related certification. So it is likely that this standard will affect future ISO standards for other certifications, including, of course, data science. Okay. This is my explanation about the current collaboration of IPSJ.
Thank you, Tetsuro. That was very comprehensive and a nice little plug for IP3. I really liked that. Okay, our next question is about future plans for certification, standards, collaborations, etc. So once again, I'll hand over to Yuri to cover that, please. About 2 minutes, please, Yuri.
Yes, I will not display my slide because it's take more time than so I also explain our activity. What the major activity that we do, we still have two projects. One is continuing developing the digital skills and data skills, where we actually reflect in practice what issues was told by previous answers on the first question, the professional issues, also attitude, and we deliver the real practical courses. But next, what we do is to try to organize, train the trainer. Because if the IT specialist, computer specialist will try to teach maritime, say, professionals, they need a translator. And we are facing this kind of translating the knowledge, transferring knowledge from one domain to another domain. Another issue is, okay, we, as I mentioned previously, we are working on the new release of Edison Data Science Framework that will have updated body of knowledge, extended this data stewardship competences, and also use cases. So we invite contribution. And another issue that we started looking at artificial intelligence competence framework. Because as you can look at the market, how a company looking for artificial intelligence engineers, a specialist, they actually don't have a clear understanding what is artificial intelligence specialist or engineer need to, which competences they need to have. And we again using the Edison Data Science Framework methodology to do this. And once more about certification, since the project, during the project, we try to initiate and create a commercial certification program. Our certification company at the time decided, commercial, that they will not develop any new certification program because technology changed so quickly that only classical certification programs are commercially viable. So this is not related to standardization bodies. The activities regulate different motivation, but commercial companies are still have this opinion. Okay.
Thank you, Yuri. Lillian Boots, I keep reading your name there instead of just calling you Boots, just to confuse me. What are your organization's future plans, ACM and ABIT?
So both with ACM and ABIT, the fact that data science as an evolving discipline is certainly in everyone's mind. ACM has published their curriculum guidance for computing programs in data science, but nobody thinks this is something written in stone that is finished and will, be the standard forever. This can't happen in a field as dynamic as data science. One of the ongoing efforts is the ongoing collaboration with other disciplines, in particular with the mathematics and statistics community, to more completely define the needs for specific areas of mathematics and statistics in the context of data science. I'm really very pleased with both of these efforts in that we did not have people in computing say, well, I know what's needed for everything and here's what it is. Everybody was very clear that we don't have all the answers, that computing is a very important part of data science, but it's not all of data science, and that we need the collaboration and the interaction with certainly the statisticians, but also with the domain specialists. And so continuing that collaboration is a very important task. Right now, a big important thing happening at ABET is that the very first programs accreditation visits are happening in data science. This is the first year. So you do a lot of work, you make a lot of effort to define what it means to be a legitimate data science program. And then you put it to work, and hopefully we will find that, in fact, the criteria that's been developed is effective in doing what ABET does, which is to guarantee a certain level of quality in every program that has that accreditation. So working through the first round of accreditation activity will be very, very interesting. But I guess I really want to emphasize that this is an inherently interdisciplinary program field, and no one area can completely specify what it takes. And the ability to work with others and to keep open the fact that this is not just something that applies to business. It is not just something that is bioinformatics. It is not just something in any one context, that it is as broad as anything ever was. And the need to have this interaction and communication among all possible fields is the challenge and the joy of working in data science.
Thank you, Boots. Now it's over to Kiwal to talk about your future plans and collaborations, for collaboration rather.
Great, thank you very much. Yeah, I forgot to mention that we're also working with Informs on their Certified Analytics Professional Program. So there are many, we've been a society of professional associations. So our approach is to help the professional associations credential people, and then to help the universities and colleges continue to improve their teaching and learning methods in terms of fitting to the outcomes, learning outcomes as specified by ACM and ABET. So really there's two sort of threads to how ICCP works. And one is professionals from industry being brought in to create subject matter expertise. We continue to have almost weekly and even twice a week meetings to keep all the examinations up to date. So as was mentioned by Yuri and others, it is an incredibly fast changing environment that we work in, and trying to keep our examinations and trying to keep our content of the examinations up to date is one of the biggest challenges that I face on a daily basis. And thankfully, we have so many experts from industry that join us to volunteer their time to keep these exams up to date. But really, my biggest future goal is to try and it's a really big stretch goal. It really is to try and see if we can begin to really have this whole concept of generally accepted data management principles come to the foreground. Our collaboration that I want to work with so many other people is on how do we build these core data models by industry? How do we have different ways of creating unique identifiers for a global industry? And how do we do record governance, record governance and ownership and transfer protocols like an enterprise network of opportunities? And how do we secure all the data using blockchain processes? So all of these 4 or 5 topics are really the focus of where we want to go down the road. And we're really working hard. We've got a model in place for some of these, but we really need to find some researchers who want to work with us to get some grants, to build out the systems that we have, and to make it an open source project so others can benefit. So we have a lot of these models implemented within SAP, within other products like Oracle, PeopleSoft, and so on, but they keep all those models inside their own environment and take an incredible amount of money from companies and from business and industry, from governments, without giving us the ability to evolve our profession in a big way. So I'll leave it there. That's really our biggest goal. That's where we're focused as an organization, that we want to go in this direction. Thank you.
Thank you, Kiwal. Tetsuro, over to you, please.
Your audio is off, Tetsuro.
Oh, I'm sorry. Well, IFIP announced its data science strategy this April, which is closely related to data science education and certifications. So I would like to introduce this. So, okay. Sorry. Okay. In this strategy, IPSJ declared to establish the framework for systematic education and certification for advanced IT professionals and contribute to the data-driven society. And to realize this concept, IPSJ is building a systematic framework for data scientists from elementary school to specialized IT engineers. Since the framework will be quite large, IPSJ is willing to promote inter-university collaboration and sharing of educational contents related to data science curriculum standard. For this purpose, online education will be quite useful to facilitate this. IPSJ is also willing to promote utilization and cooperation of related activities. So this is the outline of the IPSJ framework. The Consortium for Mathematics and Data Science Education and the Japanese government has developed two data science model curriculums and a governmental accreditation scheme for data science program. So many of the Japanese universities are working to get accredited by this accreditation scheme. However, this scheme only covers the literacy and the middle levels. So IPSJ is planning to cover the higher levels. Recently, the Japan Data Scientist Society created an online testing for level 3 for data scientists. This test will also be integrated into our framework. We are planning to integrate many of the activities related to data science education and certifications. Okay. Okay.
Are you done, Tetsuro?
Yes.
Very short and sharp, but very well structured. I think we have a good idea of where IPSJ's strategy is taking them, and it was very useful to see the ECF and the SOPHIA and the IPA levels, because those of us who know the different frameworks will understand that. And for everybody, what IP3 does is it benchmarks levels, so it uses SOPHIA level 5 for professionalism, not because we're promoting that framework, but simply because it gives us a somewhere to stick a pin or stick a pole in the ground. Getting my metaphors mixed up here. Okay, so now for the next, we're coming up to 4 p.m. in Vienna. In Cape Town. So we actually, for the next 10 to 15 minutes, in fact, 10 minutes, we'll just ask the panelists to talk amongst themselves about what's happening, to ask questions of each other. And when that's finished, we'll go to questions from the participants. Thank you. So, I think put your hand up if you want to speak, and I will, give you the floor, as it were. Yuri.
Yes, okay. I will start. Actually, I'm impressed by work by in Japan, in United States, and ACM, and we probably needed to include more specific topic in our discussion, cooperation between all these initiatives, all these activities. We are currently working more on the project-related basis, but we actively develop the area and methodology. The other speakers, other presenters working on more formal approach. Maybe we would benefit from once more establishing cooperation.
Thank you. Boots, you switched your mic on, so I thought maybe you wanted to talk.
No. So if it's okay to look, well, I'll stop until see if anybody else has something to say.
Okay. Kirill, Tatsuro, Kirill?
Yeah, so I'd be very interested in figuring out how to work on the generally accepted data management principles and the generally accepted application development principles. I feel our industry really needs to mature. We've been around, what, 60, 70 years maybe as a computer industry. And what would be really useful is if I could engage ISPGA, PJ, and Edison in some of those discussions. Now we can take them offline. We don't have to do it during this forum, and others like IP3 and SOPHIA standards. We need to figure out there are these standards, but then we need to evolve to a different kind of a higher level standard to help the entire industry. So one approach is academics, and the other approach is, of course, how do we move industry to be a much more professional industry? Today we still have so many projects that are just constantly failing, and I'd love to see us work together.
Thank you, Kirill. IP3 would be very happy to facilitate some sort of task group that looks at what you've just talked about. And the interesting thing is, when we started IP3, we had our first task force meeting in 2007. One of the big rallying calls was how many projects fail. And many years on, nothing's changed really. And with more complicated areas such as data science, I think that the failures are possibly more expensive. I mean, that's just an observation that it's even worse to fail now than perhaps it was 20 years ago. Tetsuro, did you want to add something? And then Yuri?
Yes. Actually, there is a long history about collaboration between universities and industries, and many of them failed. But in the case of data science, I think there is a chance to make a progress between the collaboration between the academia and industry collaboration. And this is because the Japanese, one reason is because the Japanese government is willing to collaborate, willing to join universities and industries. One reason of this is that the Japanese economy is recently declining, so they are willing to promote Japanese industry. To this end, the Japanese government is willing to promote Japanese universities and to collaborate with industry. The data science and domain is one of such hot topics, so that the governmental accreditation, which I mentioned before, is one example of such collaboration.
Thanks, Tetsuro. Yuri, you have your hand up?
Okay, yes, I'm typing one answer, but I would say that here, I think I would promote European experience and development in sense of data management and promoting fair data principles. Sometimes it's a fair, findable, accessible, interoperable, reusable. It's a part of the European program, framework program for almost 4 years and also planned for next 7 years. Positive was this really data is concept is promoted how to make data shareable and that easily usable and reusable by researchers. And this also creates not only metadata profile, it's also create a need for training and to define in a professional profile. And this initiative, what I also mentioned, European Open Science Cloud, will be developing this further, and cooperation would be interesting. There will be a lot to exchange, experience and results.
Thank you. Anybody else before we open the questions for the floor? So I will take the privilege I have by sitting in this moderator seat to ask a question of my own. Our minister who was in charge of ICT, she isn't anymore, but anyway, she announced about a year ago that she was going to create 1 million data scientists in a year. And now, you know, when I finished rolling around on the floor laughing, I sat and thought about it and realized she had no concept of what a data scientist does. And it just occurred to me then that there is a large amount of confusion between a data analyst, data management, and data science. And so how do we, you know, what can we do to limit the confusion on these topics so that people don't think that they're interchangeable? Any ideas?
That's a tough one. That's a tough one. I mean, you know, I'll go first if you don't mind. I mean, I shared. Let me share the screen a little bit again. You remember I showed so many different job types that have just exploded in the data space. I mean, this really highlights exactly the problem that we're. Oh goodness, I didn't want to go there. Where did it go? There we go. I mean, look at all the business roles and the IT roles, and now the hybrid roles that are emerging. How do you define all these jobs? And so, I mean, we've been working with the Department of Labor to help to get them to even create new job definitions and then the skills requirements. So I think there's a lot of room for us to sort of do this. Now, in smaller companies, of course, there's one person performing all these roles.
Yeah.
You know, and so how does one person get to perform all these roles? So I'd love to see some kind of projects within our groups to try and do this. So I'll stop sharing now, but I just wanted to illustrate how complex our task is.
Thank you. Tetsuro, did you want to say something? You looked poised to say something.
Well, actually, the role of data scientist is very broad. So as you said, data analysis is a role of a data scientist. It is not the only role of the data scientist. So, for example, data management and data collection is also a role of the data scientist. And so I think the area of the domain of the roles covered by the data scientist is very large, and so that the first thing we should do is to define the domain, the working domain of the data scientist.
Thank you, Tetsuro. Anybody?
I'd like to support Tetsura's remarks and say that it is a very broad field, as you've seen in all of the presentations about programs and frameworks and curricula and criteria, and that in cases of substantial projects, data scientist is a team, not a person. Almost has to be, because you need the expertise in the domain of the data, because otherwise you don't know how to interpret it, understand it, interact with it appropriately, and you don't know how to define what it is you're trying to get out of it. You need the computing expertise, you need the statistics expertise, the mathematics. You can't really expect one person to be the top level expert in all of those. In small projects, maybe you can get by one person being the core and talking to some other people, but in general, it's a team that's needed, not a person. That's
Thanks,
me
Boo.
personally.
No. I think you reflect what everybody's saying to some extent. And certainly when there's a different profile for the person, it doesn't help to try and make a one-size-fits-all kind of person. Kawal?
Yeah, I just wanted to reinforce Boot's comments here. And certainly we've got David Horvath, he's a VP with one of the banks in the US. And we've spoken at length about how do we not waste the time of data scientists, because constantly all they're doing is trying to figure out how to get data and how to make it available to themselves, and then how to make sure it's clean. And so the role of the data engineer has emerged, where people who can get data for you, to get the data together for you and from various sources, and then make that data available in a high quality manner for the data scientists. So the team aspect that Boots mentioned, absolutely right on the money. And I don't know if David wants to make a comment, but certainly he's done some great data engineering work over the years.
Thank you. Yuri, I'll give you one more minute to close, and then we'll get on to panelist questions, or the delegate questions.
I want to enforce comments by Boots and Kawal as well, because the next stage in data science adoption and making it effective is implement them into production. And currently we also would say investigating and developing so-called data science project operationalization. So we are defining which tools, which methodology exists to make data project, data model implementable, deployable, and also updated during operation. You probably may find like MLOps, data ops, and we are looking currently at a technology called the SRE, Site Reliability Engineering, that focused on the optimization of data model during the operation. And I have already 2 presentations at this time and recently, and interest is really cool, strong to this.
Thank you. Okay, I'll get on to the questions now, and then I'm sure they might bring out some more comments. So a question from Don is for the Edison project, Yuri. How do you get faculty who can address all the changes in the curriculum?
No, and we even don't expect that they do changes. Say nobody can make faculties to change what they don't have or don't know, what don't have sufficient resources to do. It's reality. But we treat body of knowledge, data science framework as advice and a way how to develop. So they can start with whatever they have. Surely, definitely they will fit into some advice from our framework and from what is presented today. But next they may further develop, further extend as they grow their staff, they grow their assistants, and so on.
Thank you. The next question is also from Don, but it's for Boots and Carol. How are ethical issues raised by Carol and in IFIP, ACM, ICCP Code of Ethics addressed in the curriculum?
So I'll mention that if I may.
Thank you, of course.
The curriculum that I'm talking about is the data science curriculum. You know, ACM has a code of ethics, so it handles ethical issues on a larger domain. But within the specific context of data science, most of the ethical issues are addressed in the parts of the specification that are listed as dispositions. So it used to be that ACM only specified knowledge areas. Now they specify knowledge, skills, and dispositions. So I'll give one just quick example so you'll know where to look. But in the area under social responsibility, which is one of the areas, it says accurate and ethical handling of data through computing systems or channels, recognizing the public and private implications in society of inappropriately doing so. That's certainly not everything. It's just one little snippet that shows where the ethical issues are addressed within this curriculum document. Look primarily under the dispositions tags associated with each knowledge area.
Thanks, Boots. I have another. Yeah, did someone else want to answer? Yeah, go, Kewell.
Just wanted to add to Boots' comments, and that's, you know, maybe we really need an ethics exam. That's, you know, it's something that would be used by all the societies and all the colleges. That would be just vitally useful. You know, we have we have an ACM ethics code of ethics, but, you know, we need some way of then providing some central easy way for all the colleges and universities to then put it out to the students. Now, at the same time, my comment earlier about biases, you know, we have a North American or a Western society bias to our ethics statements. And so maybe it's not the same in other countries. And so I'd be interested to hear some comments about how do we implement that same model. I guess we can't, but it may be interesting to talk about it.
Thank you. Tetsuro, I'll hand over to you for a minute, but I was thinking that we were finishing at 6:30, but at 4:30 rather. And in fact, it was a 75-minute session, so we should have finished 2 minutes ago, indeed. So did you have some closing remarks, Tetsuro?
Yes. Well, let me see. Okay, let me share my screen.
Okay, thank you.
Well, and so actually, let me share my screen. And sorry. As a closing remark, I think COVID-19 is quite a disaster to the entire world, but it has also triggered the digital transformation of the society. In many universities, online education becomes popular, and the students can learn at any place and time. So the data science is one of the key technologies in our society through various types of data collection and analysis. So I'd like to contribute to both quality assurance of data science education and certification systems to prove ability of digital human resources. So, I'd like to say thank you for everyone for joining this event.
Yes. Thank you very much to everybody. Just quickly, and Tetsuro, thank you so much for setting up this discussion on such an important topic. And hopefully through email, we can all talk about it some more and figure out if we want to take this discussion further. I certainly hope so, from an IP3 point of view.
Well, actually, we would like to have more time to make a discussion with other panelists. But anyway, we have to close the session.
Tetsuro, I can always set up a separate Zoom meeting for us to have a discussion if the other panelists are interested. So I think that will be a very good idea. So thank you all. More importantly, thanks to the participants for coming and listening to our panelists. And thanks to Christina and GR for setting up this Zoom session. Thank you.
So also again, on behalf of the GI and on behalf of the IFIP Events Coordination Committee, thank you very much to our panelists and to the organizers. Thank you, Moira, for the lovely moderation. And thank you to all of the participants of today. If you would like to follow more on the upcoming events, please visit ifip.org/Jubilee60 and also make sure you follow IFIP on Twitter and on LinkedIn so you don't miss the exciting activities and events that we have planned. So thank you again, and I wish you a nice afternoon or morning or wherever you may be.